Okay, hello PVHS students. This is the second part of the CPM 5.2.1 water balloon contest. Let's create 3 buttons so that we can control this contest and then we can analyze it at any point, at any time. So we need 3 buttons. Okay, we'll put them over here somewhere. The first button is Start Contest. And our just GeoGebra script would be Start Animation. And then you're going to put the bracket A, and then you can copy this. Notice that the S and the A are capitalized. And then we're gonna start animation for each of the sliders. So this slider is B, and then this slider is E, if you remember. Excuse me. And this slider is I, the slider name. So we're telling it start that when we press that button. Okay. So start contest. Oops, cancel. Okay. Make sure you're on your move menu if you want to do anything, because it'll create another button. So notice that it starts it. So if I stop this one, then if I started it, it would start it. Okay, D. So I don't know if you saw that. Okay. So then let's have another button for stop, just in case you want to stop it in midair and see who might win. And we're just gonna say start animation false. So it tells the computer that no, there should be no animation on. Okay, so then if we go back to our move menu, because we don't want to create another button, and we say stop, it stops. We say start, it starts. We say stop, it stops. Okay, now we need one more button, and we'll place that here, and we'll name it reset, so we can reset it, so we can say, okay, we're gonna start the water balloon contest all over again. And we're gonna say the same thing, start animation false, and then we're going to reset all of the slider variables to their first leftmost point of their domain, or where they start, basically their first, where they launch, where the balloons launch from. And so Jen's throw is 0, right? And E, I think, started at 2, correct? And I started at 10. I think that was right. 3, 0, 2, 10. 3, 0, 2, 10. And then we want to refresh the screen, so we're going to say zoom, capital IN, open parentheses, 1. Oops, 1. And that should refresh the screen for us. So then let's go ahead and press the move so we don't create another button. And let's reset. Okay, so we're at the start of the water balloon contest. And let's start the contest and see which water balloon travels the highest. And we can stop it at any moment just to take a wild guess where. We can stop it right there, and we can see that B is the highest, Jen's throw, right? So she was able to have the highest height value. We should continue, right, by starting contest, and let's see who went the farthest, right? And we can stop it right there because we can really see already, right, who went the farthest. It looks like, but they started earlier too. So who truly went the farthest, and how could we solve that problem, right? Because whoever you went the farthest depends on where you start. Well, hopefully you enjoyed this animation to simulate what we're doing in class by hand. If you really noticed here, the parabola slows down. It kind of speeds up as it falls down. Notice that it looks very similar to something that an object that gravity is acting upon, right? Like a rocket that's shooting up, but then the gravity is kind of pulling it down, pulling it down. And so mathematically, a parabola describes this perfectly, without neglecting, air resistance, wind, um, the actual friction of any friction through like the barrel that it's been shooting out. This is ideal mathematically, but it models it pretty good. So I hope you appreciated it, and we will. That's all the time we have for this video, and we'll talk about it more in class. Oh, before I stop this video, save please. Okay, save as water balloon contest 5.2.1. I saved it as part one. You can make sure it's public. You could just save it as 5.2.1 because you probably have just one file. Okay, signing off. Hope you enjoyed this, and see you in class. We'll discuss this more in class.